In this video, we are going to be exploring histograms. Let's begin. So a histogram is a kind of chart that shows data by using intervals or ranges. Now, why would you want to use a histogram? Well, a histogram can actually simplify data and make it easier to read. You're going to see in a moment how this data is sorted out and displayed. So, for example, surveys often ask the age range of the participants. Brainstorm any other ranges that would be applicable. Well, let's dive into age range. So what that means would be, example, ages 11 to 14, or you can say ages 20 to 30 and ages 31 to 40. Those would be age ranges. We're going to see in the next slide how that can be applied to a histogram. You can also have range of price you'd be willing to pay. So some people have different prices they'd be willing to pay. Some people may say, oh, that t-shirt I'll spend between $10 and $15, but I'm not going to spend more than that. Or range of sizes you would buy. So for example, some people can wear pants that are between 28 and 30. So let's apply this to an example. Data from the National ACT exam is shown in the histogram below. What observations can you make about this histogram? What do you notice about the intervals? So the intervals are these sections right here. So 1 to 5. Now these are the score endpoints, so it looks like the lowest score one can get is 1, and the highest score that someone can get is a 35. Now, how many people scored between 1 and 5? It looks like probably one person, and one person scored between 6 and 10, but the intervals are these right here. So one person got a score of between 1 and 5, and another person got a score of between 6 and 10. We have another interval which is between 11 and 15, and notice all these intervals are roughly the same. They're all between 5, 1 to 5, 6 to 10, 11 to 15. So what do we notice about them? They are all equally sized and they have a range of 5 points. So how is a histogram different from a bar graph? Well, histograms can show a range of answers versus a single value like a bar graph. So if this was a bar graph, you wouldn't have 1 through 5 and 6 through 10. You'd only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you would not have ranges of data. Each of these numbers would have their own individual bar. So if the highest score is 35 and the lowest score is 1, you would have 35 bars. So number 3, how is a histogram similar to a dot plot? Well, they both show you the overall shape and spread of the data. Now you can see that this shape looks like kind of like a bell curve. It skews a little bit to the left, but not that much. And finally, would it be beneficial to display data in a histogram, or when would it be beneficial? So when the data spans a large range. So as I said before, you don't necessarily want 35 bars or to draw 35 separate bars. A histogram can be very useful because it reduces the amount of bars and simplifies the information. Another reason you may want to use a histogram is when there's a lot of data. So it's wiser to use a histogram than a dot plot when there's just too much information, because when there's a lot of information, it can be difficult for a person to read that data. So let's do an example. A line of 30 customers at the Department of Motor Vehicles, that's the DMV, were surveyed. Their ages are listed below. Now, the Department of Motor Vehicles, if you didn't know, that's where you would go to take your driver's license test and to renew your driver's license. So it's a very busy place. So the ages of these people in line are listed below. So we have 32, 56, 42, and so on, all the way up to the end. Now, place the data in a frequency table below based on their age, then create a histogram to display the data. Now, before we create our histogram, we need to put it in a frequency table. This is my frequency table right here, and basically this is how I organize my data. So my age range is 1 to 10, 11 through 20, 21 to 30. Something to note, in this example, they go from 1 to 10 and 11 through 20. Normally when I set my age ranges, I would go from 0 to 9 and 10 to 19, and the reason being is because it just makes it easier to organize. But it doesn't matter. However you set it up is up to you. So let's begin. What I do is I'm going to cross off 32. So 32 gets crossed off, and it goes right here in this range, 32. So I'm going to put a tally mark right there. 56 gets crossed off, and it goes to the 51 to 60 range. 42 gets crossed off, and it gets put in the 40s category. 16 gets crossed off, and it goes over here. 74 gets crossed off, and it goes right over there. 53 gets crossed off, and it goes over here. 38 gets crossed off, and it goes over here. 26 gets crossed off, it goes over here. Sorry, down there. 45 gets crossed off, it goes over here. 40 gets crossed off, and it goes right over here. And that's a weird part, was this feels like the 30s range to me, but it goes from 31 to 40, so it actually goes over here, not down there. So right there. 56 goes over here. At this point, you can pause, tally it up, or fast forward and check to see if your answer is correct. 51 goes right over here. 16 goes right over here. 18 goes in that same box. 29 goes down over here. 47 goes over here. 38 goes over here. 36 goes over there as well, and right there I'm going to do a cross. So if you've never done tally marks before, they're arranged by fives because most people can count by fives, 5, 10, 15, 20, and it organizes your lines a little better. So don't just draw a fifth line down, do a cross, and every time you see a set like this, it's a group of 5. So 48 goes over here. 57 goes over here. It looks like our next set of 5. 52 goes over here, so we're going to do a sixth line. We're not going to do a second cross. 49 goes over here, next cross. 31 goes right over here. 35 goes in that same area. 19 goes in our teens. 21 goes right over here. 66 goes down there. 64, same place. 24 up here. And finally crossing out 39, our last number, woohoo! And it goes right over here. And now we're going to count up our tally marks. So the frequency is how often something happens, how frequently something happens. In this case, how frequently where people's ages range in the 1 through 10 range. 0. There are 0 tallies there. For how many people were between 11 and 20? Well, 1, 2, 3, 4. It looks like 4 people were between 21 and 30. 31 to 40, we have a group of 5. 6, 7, 8. Look how easy that is to count. And then 41 to 50, we've got 5 people. 51 to 60, we've got 6 people. 61 to 70, we've got 2 people. 71 to 80, we've got 1 person. So now that we have our age range and our frequency, we can display that in our table. So something to remember, when you draw a graph, this is like our x-axis and this is our y-axis, and x goes before y in the alphabet. So if we look at our table, we have our range and our frequency. The tally is basically just another way of doing frequency. So the age range is always going to go horizontally sideways with the x-axis. This one goes y, alphabetical order, which means it's going to go up here, frequency. All right, let's get back to it. So our age range, our first age range, and notice it's not going to be on the line. It's going to be between this whole area. So this whole area is between 1 and 10. And then our next one is going to be 11 to 20. Our next one is 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80. And then there's not an 81 to 90, but why not? Frequency. How often something happens. The lowest number is 0. The highest number is 8. It looks like we do have enough for that. Each line could represent 1. So the 1 goes on the line. It's not the actual box. So 2 is on the line. 3, 4, 5, 6, 7, all the way up to 10 at the very top. And then let's fill it out. So between 1 and 10, 0 people, so nothing gets shaded. Between 11 and 24 people, so I am going to shade up to the 4th line, indicating there are 4 people who are that age range. I'm going to move on. 21 to 30 had 4. This had 8. Then we had 5. Then we had 6. Then we had 2. Then we had 1. So your graph should look something like this. Your histogram should look something like this. What age range, let's look at question number 5. What age range represents the center of the data? Well, it looks to be around 31 and 40. Seems to be the center of our data. It's our peak. Why do we suppose, or why do you suppose that there was no one between the ages of 1 and 10 in line? Well, that's interesting. A lot of you might be stumped and thinking, I don't know, because the graph is supposed to look like a curve. Well, no. Think about the question. This is not necessarily a math question. It's just a, kind of a logic or common sense question. There's a line of 30 customers at the Department of Motor Vehicles. Remember, this is a place where people go to get their licenses. Would there be a lot of people between the ages of 1 and 10 trying to get their license? No. So kids under 16 can't drive. It looks like there weren't that many parents who brought their kids. So that's probably why there weren't very many young people at the Department of Motor Vehicles. So what's the overall pattern that we see in the data above? It's like a bell curve, and this is what we call a bell curve. It starts low, goes up, and goes back down. So this is our bell curve. And why does it seem to be a bell curve? Well, bell curves are low on the left because young people can't drive. Why does it peak in the middle? Well, because a lot of people who are older do drive. Now, why doesn't it just keep going up and up and up and up? And, between 89 and 90 and 90 to 100, how come it doesn't just keep going higher? Well, it's because older people typically stop driving, and a lot of people in the 100 to 110 category, they're not living with us anymore. So as you go up in age, people stop driving for multiple reasons. Sometimes because they get older and they're not comfortable. Sometimes they're older and they're not with us anymore. Last page, data on a histogram. Something to know is that it can be skewed to either the right or left. Now, this word skewed can be really confusing. I get mixed up on it all the time. If you look at this data of basketball points, it's skewed. It's not like a bell curve that is low on the left, peaks, and then low on the right. It is actually skewed. If you look at the height of pediatric patients, it's not low on the left and low on the right. It's low and then gets high and then it starts going down, but it's still higher on the right side. And this one's higher on the left side. So this one is actually skewed, not to the left, but to the right. You would call it skewed right, which is kind of bizarre. Now, what's something that will help you remember? Well, the tail, if you want to call this a tail, is on the right side. So imagine this is a big animal and they've got like a tail dragging on the ground. If the tail is on the right, then it is skewed on the right. Likewise, on this graph right here, it is skewed on the left because the tail is over here. So the tail is on the left. That means it is skewed to the left. So now you know about histograms. Go ahead and work on homework problems. Good luck.